Howdy guys, so here we're going to do a Thevenin equivalent circuit. I never say it right. So let's just go through. What does Thevenin circuits mean? So Thevenin circuits, we could have this piece of circuit, we could have some really complex thing over there, but Thevenin says we're going to make a cut down the circuit, which is what this thing is indicating. So maybe this has a whole bunch of other resistors going in a whole bunch of things. There's power sources, or there's something else over here that's happening. But a Thevenin circuit is a way of simplifying a circuit down to a single voltage and a single resistance, since all of this essentially is a voltage source and a resistor in front of it. All of this can simplify down. And that's a way that we can quickly jump to solve problems later on. It's a fast method. So all of this equals a voltage source and a resistor. All of it. And that's the A and B. And this source is going to be something dependent on all the resistors, and this resistance is something dependent. But it's a simplification step. This is how we get to it. So let's step in. What do we got here? We got a current source, we got a whole bunch of resistors, we got a terminal A and terminal B. So let's go through and solve through this one. So first thing that we do for this is I like to, as my normal, make my nodes V1 and V2. We're not actually going to use them as much, but this makes me so I can identify them. You'll see. So first thing we do is we're going to have our KCL, and we're going to find it V1. We're going to try to find out what our voltage here is. So again, I'm going to make a nice little reference, ground. There we go. And KCL at V1, because that's right where our source is. So if we find this one, we kind of can find this one later on mathematically, but this is the most important one. So we find this. So what do we got here? We got 3 amps, we got 3 ohms, and we've got 6 ohms on this side to get to ground. So first thing we're going to do is we're going to take KCL at V1, and that's going to be ins equals outs. So coming into this one, we're going to do a 3 amp. Okay, nothing else. And then coming out, we're going to presume this comes out because we're not presuming anything's happening. It's open over here. So we have to know it comes out like that. So outs are going to equal, what do we got? V over 3? Yeah, V over 3. V over 3. V1 over 3, excuse me. So that's V1 over 2 plus 1, so 3. And this is going to be plus, we're going to go all the way to ground again over on this side. So V1 over 2 and 4 is 6. V1 over 6. And when we simplify that out, we're going to multiply both sides of that. We're going to multiply by 3. So we're going to get our V1 equals 2. So wait, hang on. 3, 6, 3 comes out. 2, 4, 6. Cool. All right, I like it. So now that we've got our V1 equals 6, that's what our voltage is at this point compared to ground. So next bit that we're going to do is we're going to try to find what the voltage drop is across some of these resistors. So what we need to do, how do we get to ground from this? We're going to use a voltage divider. And again, you can do this in any way. You just we gotta figure out what our voltages to get to ground are. How do we get there? So for a voltage divider, if we remember, we have V out equals R2 over R1 plus R2 V in. And again, why are we doing a voltage divider? Because the voltage, we have resistors here, and resistor is like the split voltage up. Just like, remember, here we have a current divider because some of the current's going this way, some of the current's going this way. So we've got our V out equals our V2 over R2 over R1 plus R2 V in. So for our V out, we're going to do our R2, and our R2 is going to be 2 plus 4, so 6. And then that's going to be over our total of, well, 1. So this is R1, so that's going to be 3 plus 6. So it's going to be times, sorry guys, times our V in, and our V in, because we already determined that that's 6 there, so that's 6, cool. And so that's going to equal, so we have 6 over 9 times 6. So let me do this in the calculator. 6 divided by 9 times 6 equals 4. And that's going to be V out. And that's also going to be something important to us. This is called the voltage theravin. So we're going to store that in a box. I'm going to show you what to do with it in a minute. So the next pit now, we have this voltage in the theravin. So we know that this is 4 actually in the thing that we're trying to solve for. So now all these resistors have to get simplified into a single resistor. So we can pull out the source and we can solve it just like a normal resistive problem because we already got the voltage source here. So now we just have a whole slew of resistors sitting around. So for this, we are going to simplify this into 3 and 4. So this is going to be, let's redraw this. This is 3, because remember 2 plus 1 is 3. Cool. We're going to go over, remember we pulled this out, so that would be here, but we kept it out. We've got a 2 here. We've got then a continuing, we got a 3 over here. And we've got a continuing down here to a 4, right? That looks good so far. Let's simplify it down more. This is going to go to a 5. Can we see that? Nope. There we go. A 5, and then we got a 4, and then we've got a 3. So, if you remember when we solved some of these before, I asked for the voltage at the tip, and we said to ignore this 3. Well, in the theravin, the 3 is going to add in at the very end because it's part of the resistance. We're not actually calculating what, we're not actually calculating anything else. We want to include this in the theravin voltages. So for this one, again, what do we got for our currents? For our resistances. Our resistance, we've got 1 over 5 plus 1 over 4 to the minus 1. So that's 0.2 plus 0.25 up minus 1. 2.22 was 2.22. And then this plus 3 is going to equal 5.22 ohms. Okay? And that's going to be special. That's going to be our R theravin. So our total R for this specific problem. So we can plug this back in up here as 5.22, and that is our solution. So let's draw our solution down here one more time. We've got a voltage source of 4 coming up with a resistor of 5.22, and this is open again, 5.22. That's it. These aren't too bad. They're just trying to simplify out this whole thing. The point of this is being this entire circuit or whatever it is, or if it's a bigger circuit, we can cut a piece of it out and we can simplify it into a single voltage source and a single resistor. And when we do that, now we have a much easier circuit to work with. So let's just say there's a whole bunch of different sensors or whatnot coming in here or something. This will simplify out into a nice, easy answer. And then we can use this for further calculations. So that's it for, what is that, 3.64.